Thank you for being here. For those of you who don't know me, my name is Frank Simons, serving as, I say serving, I don't say I am. I'm serving as your Associate Dean for Research. This is, if you're longtime followers, you will know this as a coffee break for grants meeting. I was playing around with different titles over the last couple of years: caffeine, carbohydrate, catalyst conversations, etc., etc. But these are opportunities for us to come together collegiate-wide over issues that matter, both in terms of mechanics of getting research done, and this is one of those opportunities. Over the course of the last 2.5 years, I've talked with many people over some small issues and big issues, but that converge on issues around data privacy, data use, data sharing, et cetera. And there's old wine in new bottles. I mean, data privacy has been around as long as we've had data. Who owns the data? So I wanted an opportunity to revisit those. But data sharing and data privacy in the era of and tele and virtual and cloud and all of that, we need to make sure we're thinking how, what needs to be done and what's in place at the collegiate level. So in the spirit of that, we invited some folks over that live in this space and think about it often. We have Alicia and Shonda, which as a Canadian I would have went with that soft A, and then I checked myself with an American. Shanda from libraries, and we have Tom from SPA, who are going to walk us through their slide series. We have 90 minutes. They probably have at least 45 minutes of stacked PowerPoint content. I'll let them decide how they want to go, questions as you go, but then we have time for discussion as well. Okay? So I'm going to turn it over to Tom.
Hello. So my name is Tom Schuweiler, and I am the UFRA coordinator, and we'll go through UFRA and hopefully all the other acronyms I use during the course of my 15 minutes up here. The UFRA unit is part of the Sponsored Projects Administration Group, sometimes called SPA. Common misconception, there is no spa at SPA. There's no steam room, it's not a good place to get a rub down. Very disappointing. I should have checked into that before I got hired. One more note before I start, you'll see the Spectrum logo. I don't know if that means anything to you. I repurposed this presentation out of a Spectrum class. This is not the whole class, so you don't get credit for taking the class. So, UFRA, it means two things. First of all, it stands for Unfunded Research Agreement, and it is also the database in which university employees can check the status of a particular unfunded research agreement. And an unfunded research agreement is any kind of agreement that's A, research related, and B, does not have incoming dollars attached to it. So it's not funded. Because these agreements don't have money attached to them, they're not bringing in funding, they sometimes don't get the respect they deserve, especially some of them are very short, just 1 or 2 pages, including the data use agreements that I'm going to spend most of my time talking about. But they are binding agreements, and the university agrees to do or not do certain things, and there are consequences if we don't live up to our obligations. So I am on the UFRA team, and my job is to negotiate those agreements to protect the university, to protect the work being done here, and to protect university employees. And the activities covered by the unfunded research agreements with which I work include confidential discussions, confidentiality agreements that allow people to talk about perhaps something that they're going to work on in the future and disclose confidential information to each other. Requests for research materials from external sources, or if we're going to send something out, some materials out of the university, that would be a material transfer agreement, or MTA. And most relevant to today's discussion, the sharing of data between institutions and or from databases. So Unfunded research activities are almost always carried out. Every once in a while, there's something that's done informally just between two PIs. But generally, they involve a contract, just like a clinical trial, just like any other research agreement, and the contract lays out the parties' expectations and specific responsibilities. Most of the agreements we receive, even the one-page ones, can't be signed as is, and that's what I'm getting back to that thing before about how sometimes the agreements, people will send it to me and say, I need you to sign this form. It's like, well, it's not a form, it's a contract, and if we don't live up to our end of it, or if we accept something we can't, the university is going to be liable. And indeed, some unfunded research, data use agreements especially, can be just as complex as any other agreement. They're requiring university approval, for the usual stuff, property, space, faculty effort, students. Sometimes they require the input of the Office of General Counsel for legal matters, or the Office for Technology Commercialization for intellectual property matters, Privacy Office for data use, and on and on. So unfunded research agreements, they're signed and sponsored projects because they bind the entire university, not just the PI or the research staff doing the work. And that's good for everyone, including the PI and the research staff who kind of maybe want to just sign it themselves and move on because they probably don't want to be held liable if something goes wrong. So, unfunded research agreements. I'm not going to go through all of these, the alphabet soup of all these things. These are among the different kind of things that you might see and that my office works with. Like I said, we're going to concentrate on data use agreements. But what all these agreements have in common is that they obligate the university as a whole to do or refrain from doing something, and they're negotiated and signed in my office at Sponsored Projects Administration. So, a data use agreement is a contract used for the transfer of data, specifically a data set. Because I was talking to somebody about a confidentiality agreement, and she said, well, isn't that data? And I said, well, you got me there. I guess anything somebody tells you is data, but data in this sense being the kind of thing that you folks work with, some group of data that's been developed by some organization, could be a nonprofit, a government, private industry, where the data is not public, it's a secret, and because of that, it has some sort of inherent economic value. They've got a set of data that they've developed into maybe a database or just something that they have that's valuable because of what it is. And so a data use agreement is an agreement about that subjects the university to restrictions on our use of that. So a data use agreement, besides containing things that are in all university agreements, confidentiality, governing law, all that good stuff that I'm not going to go over unless you really are dying to hear about it, usually has most of these elements. The subject matter of the data to be provided, so that is, what is this data that this party is letting us look at? The allowed uses for the data. It's usually restricted to some specified research and research project, a scope of work that's often an appendix to the agreement itself. Who will receive the data and who's allowed to see it? Again, because these are agreements with the entire university, people generally want to restrict. Not everyone who works here can see it. It's usually basically just people who need to. So the research staff and then anyone else, maybe legal or me or someone like that. How long the data can be used, and at the end of its use, how it's to be returned, discarded, destroyed, wiped from the computers, that sort of thing. The ways that the data can be analyzed and can't be analyzed. How the data must be aggregated and de-identified if it's not sent to us that way. And another element is a process that allows for the data provider to review any draft publications before they're sent anywhere else. And this is for a couple of reasons. First of all, so the data provider can be sure that, one, that the data subjects are protected, that nobody's identified, that they can live up to their obligations to the subjects of the data. And two, so that they can verify that none of their confidential information is.
Ask a couple questions. One is, if it's, we have the data that we're sharing, do we still need a data use agreement, or is that the other item that has to be?
Yes, most of the time, and we'll go over that. Basically, if it involves human subjects, you have to have some kind of agreement under HIPAA. If it's data about something else, and we truly don't want to put any strings on how somebody uses it, or intellectual property provisions, then there's a chance we wouldn't, but almost always yes.
So the other part is if we have a grant, if we're obligated to provide the data some in the future. Once the funding ends, are we now unfunded at that point, or?
No, whatever your use of the data would still probably fall under whatever your obligations are under that agreement.
But if there are obligations to make the data publicly available, are we covered under this then or not?
That would be a separate agreement. You'd be covered under that agreement. Does that make sense? Okay. And so publication, so one thing that's going to be in every data use agreement is publication, things about that I talked about. And then of course statutory, federal HIPAA is federal law. And so there's usually just a sentence in there that says the parties agree to obey the law. And this kind of gets to your question. So how data use agreements are handled, how data coming in and going out of the U is handled. So you can see all this, which is, of course, because it's the University of Minnesota, needlessly complex. So I'll go through the rules and then I'll give you the easy version. For incoming data, so somebody sending some data to us, that comes to my office, UFRA, and you can see here, UFRA is responsible unless it's a business associate agreement. Sometimes it'll say that at the top, usually it does. If you're not sure if it's incoming data, just send it to me. If it needs to go to the privacy office or the Academic Health Center privacy office, we can work through that. Outgoing data. Office for Technology Commercialization is responsible for those agreements unless it's patient data generated here at the U in a clinical or research thing. So again, the short version is if you have a data use agreement, just send it to me and we'll cover that, how you do that at the end, and we'll figure it out together because as rules of thumb go, this one is not very memorable. So when you get an agreement, they often have different names, and of course, sometimes there are data use elements in research collaboration, part of a larger agreement. So I guess this is just a warning. If somebody sends you something, don't get hung up on the name. If it allows somebody at the university to access data, to bring data in and look at it, and attaches conditions to that use of the data, it's a data use agreement. As I mentioned before, the reason that there are data use agreements, well, there's two main reasons. One, if there's any data on human beings, you have to have a written agreement, and that's the law under HIPAA. And secondly, databases, and this is a relatively new thing, even in the 3.5 years, 4 years I've been at sponsored projects, we're seeing a lot more data use agreements now than we did then. There's just a lot more databases people are able to aggregate and get like meaningful sets of data, and so it's a burgeoning area of study. But going back, I guess it's not written here, but if you take away one thing That is, if you are transferring, if there's a transfer of information that's about people, you've got to have an agreement. And on that note, here's some of the terminology that you run into when you're talking about data about human beings. And the first one being protected health information, or PHI. And that is things, names and identifiers that reveal the identity of a person. And in HIPAA, there are 18 of them. They're very specific. They're spelled out in the law. Things that identify people, like name, social security number, address, anything you can use to figure out who that data is. Oh, that data subject is Tom Schuweiler that works at the University of Minnesota. So that's what protected health information is. A limited data set is a set of PHI, a set of protected health information that has some, but not all, of those 18 identifiers removed. So the people have, whoever has created this limited data set has gone to some lengths to make the data subjects anonymous, but they haven't done all 18, which brings us to de-identified data. That is a phrase from HIPAA, and so the legal definition of that is it's PHI, protected health information, with all 18 identifiers removed. And the reason I'm drilling down on this so much is, unfortunately, de-identified data is also sometimes thrown around informally, the non-legal term for that. And so somebody will say, well, I took out, a bunch so you can't tell who it is. And then you talk to them a little bit, and they say, well, did you take out these 18 things? Well, no. So, and so when you're looking at agreements and when you're having discussions with people and they're talking about de-identified data, you kind of have to make sure if they're promising to send you de-identified data, is it just their opinion or is it as defined by HIPAA? And that's what I do for a living.
So, question,
Yeah.
If the information has nothing to do with health, but it's maybe school records, are those 18 items still applicable?
Yeah, anything to do with the person.
So then, one of the human subjects exceptions is when you have information about public elected officials and public programs. Are those things similar for data about that?
I've never run into that, so I don't know. I would assume so, but I've honestly never run into that as being an element of any agreement I've ever worked on.
So if I'm working with a nonprofit and they keep data on their services and they want me to look at once a year, summarize and
Right.
give them trends and whatever,
Yeah.
and I'm just doing that grants for them.
Sure.
They send it to me, it's not de-identified, but that's the first thing I do is de-identify
Okay.
it and then play with it and then send it back to
Right.
them. Do I need an agreement for that?
They should be, I guess you could be working for them, so I don't know, but they should be doing that. I mean, it's not they're the ones that are sharing the data, so
Yeah.
they might want to have one.
Okay, they haven't wanted one, should I encourage them to want to have one?
Yeah, or at least explain why they think they don't need one, I guess. But again, I don't
Yeah.
see in that situation where that's you're not doing anything wrong.
Yeah.
So. Well, that brings us to my last slide, which is just the nuts and bolts of the UFRA office. And so if you get a data use agreement or any other agreement that's an unfunded research agreement or something you're not sure about, I spend a fair amount of my day in the something you're not sure about category, email it. And my email was at the beginning of this slide set, but I also answer the general UFRA mailbox. And then if you want us to review and sign an agreement, you knew there was going to be a form, and our form is called the MTAR, which stands for Material Transfer Agreement Routing Form, because we did a lot more of those when that form was named, and that's an EGIMS form. And if you need help with that, you can call the Egypt's helpline, you can contact me, or you can ask Amber, or there's a number of ways to figure out that. And then this is, unlike the PRF and a lot of forms, I am not notified when an MTARP is complete. I do about 60 agreements a month. So if we have a discussion about something and then you do the MTARP, I won't know that it's done unless you send me an email. I will completely forget our discussion minutes after I get off the phone. And then the last bullet there is just if you have a confidentiality agreement, which is often a precursor to something where you're doing a more substantive research, don't worry about doing an MTARP. Send it to the same place. UFRA, at UMN, CDA, MT, Grade, they all go to the same place. And that's all I've got. Are there any more questions?
So, a few slides back, it sounded like you said that data comes through your office, data itself will come through your office?
No. I think what you're referring to is the fact that only a limited number of people can see the data, but no, I never, under usual circumstances, it never comes through me, but we or the Office of General Counsel or something like that might end up seeing it if there was some sort of issue, but not in the regular course of business.
So SPA has a process where incoming mail get numbered and we can always refer back to it. Is there something similar in your office?
What do you mean?
So if we
Like
look
an
at
agreement?
if we have a grant proposal, we have a research project, we submit human subjects, we get a human subjects number, we can always refer back to that
Yeah,
number.
that would be the MTARP. The MTARP is a numbered thing, so when you finish it, there will be a number visible to you, visible to me, and that's the first number that everyone can agree to.
Can you say a little bit maybe about, so individual data sets can be de-identified at your level, de-identification.
Yeah.
But when you start to put those things together, you can start identifying maybe not individuals, but definitely groups of people. And how is your office thinking about that, or is anybody thinking about that?
So, this is, I think, a little bit beyond my pay grade, but you're talking about, you get a set of data and you work with it, you combine it with something else, and that allows you maybe another, is that?
Yeah, absolutely. And so you can take several de-identified data sets, put them together, and pretty much identify almost everybody.
There's usually something in every contract where we promise not to try to identify the data subjects. And so I always assume that was just something left over from HIPAA, that they said, you should put this in. That's probably why that's in there. So that even if you can, you promise not to.
I'm assuming that this doesn't apply to public use data that's put out by the
Anything that's
Census Bureau or
specifically,
anything.
you're right, yeah.
Okay. And for us, for it to be a public use document, like, we collect information that's federally sponsored. Is it the university's data or is it the sponsor's data? If we're under a contract.
Depends on what the contract says. I would guess that most of them say it's the sponsors.
I don't, in this case, think it is.
Yeah.
So
You
if
have to look at the individual agreement.
The reason it's an issue is because we get people asking for the information.
Right.
So the question is, it's not sensitive information, but what we do with it, how we organize it, how we analyze it, is our property.
And how did we get this data? Through
Collected
grant?
from state officials.
Okay, through grant?
Yeah.
Okay, so you're looking at a grant document, I guess.
That means your time is up.
Yeah, I guess. The Doug is here.
Sorry.
So, are there any more questions before I? All right, thank you.
Hello, everyone. My name is Shanda Hunt. I am from the University Libraries. I am the Public Health Library Liaison at the Biomedical Library. I'm here presenting with Alicia Hopeless-Moore, who is from CLA Lattice. If you don't know what that means, I think I can tell you. Liberal Arts, Technologies, and Innovation Services. I almost said Imagination Services. And Alicia is a research data manager there. We both work together on the research data services team in the libraries, and also for the data repository for the University of Minnesota. And so we're here to talk about data management best practices, hopefully from beginning to end. And I think we'll be able to answer some of the questions and address some of the things, fill in some gaps that maybe you guys were just concerned about with our presentation. Full disclosure, Alicia is your expert here. I am a novice, so I will do my best to answer all your questions, but if you have questions, Alicia will be answering those for you. So what is data management? Data management is the practice across the research lifecycle of a project that ensures integrity of the data, so accuracy and consistency of your data, and facilitates replication. Just like having accurately written protocols helps you write a method section that is replicable. Having great data documentation will enable folks to be sure that the data can be regenerated in a similar fashion. It also protects the security of the data, so it protects any human subjects or minimizes data prevention loss and protects data from unauthorized parties gaining access to the data, and also enhances efficiency and reliability of the research. So it enables you to expedite the scientific process, saving time and resources in the long run. And also, careful documentation gives the data authenticity and garners trust among the research community. But what does that really mean? So it means thinking about and planning for, from the very beginning, things such as file naming conventions, folder structure and how to manage that folder structure, documentation and metadata, which is data about your data, storage solutions, backup plans, and security, and also sharing and preservation of that data for several different reasons, for funder requirements all the way to data is gold, so you want to keep it long term. Why should you care? So we have the stick, which is data management plans are now frequently required by several different funding organizations. In 2013, the Office of Science and Technology Policy released a memo regarding public access to research. I'm going to read that to you guys if you haven't heard of it yet. So this is an executive order making open and machine-readable data the new default for government information, taking historic steps to make government-held data more accessible to the public and to entrepreneurs while appropriately safeguarding sensitive information and rigorously protecting privacy. So I did look up, I'm making the assumption that a lot of you are funded by the Department of Education, is that correct?
Health and Human Services.
Health and Human Services? Okay.
NSF.
And NSF. Okay, so all of those do have data sharing requirements as of about 2016. There's also journal requirements, ensuring that the underlying data of the publications are made available to the public. And also different types of professional societies are coming up with ethical standards regarding sharing of data. The carrot is that having careful data management and documentation saves you time in the long run. If you're sharing your data, it also increases your citations. That is a work product of yours that generates a citation that can be used to give you credit for someone reusing your data sets. And also demonstrates your integrity as a scientific research by showing transparency in the work that you do. So, one of the scenarios that could potentially happen is 3 years after completing a study, someone contacts you, a researcher contacts you wanting to use some of the data or materials to replicate your work. And your concerns could perhaps be that you're not able to locate your files or materials. They are potentially stored in a place that you can no longer access. The files could potentially be corrupt or in a format that you no longer have the software to read, or the software doesn't exist anymore. And do you have the documentation about how you created, analyzed, and made use of the data materials that still makes sense to you and to others? I thought this was really interesting as we were putting together this presentation. I'm actually simultaneously doing data management interviews with public health faculty, and part of it is asking about data storage, going back to old data, data loss, and out of the 10 faculty that I've spoken to, only one has not lost anything. And as I probed deeper, she explained that they have a full-time data manager on staff who takes care of everything. Otherwise, they had 20 years after the fact been asked for their extensive protocols because their study was being replicated by someone and they could not locate an electronic file, so they ended up digging through people's offices for the paper copies of all these protocols. So just a couple of examples of why this is important to think about from the very beginning. A data management plan is what's often required by funders in the grant application. So 5 main questions to consider: whether this is for a grant requirement or not. It is just to keep yourself organized and knowledgeable about the data that you're collecting. These are some 5 questions that you want to consider. What type of data or files will be produced or used? What are the standards that will be used for documentation and metadata? There are metadata standards out there for different types of disciplines. What steps will be taken to protect the privacy, security, confidentiality, intellectual property rights, or other rights? If you're allowing others to reuse your data, how will the data be accessed and shared? What are the data use agreements there? And how will the data be archived for preservation and long-term access? So getting into the types of data that can be produced. Consistency is very important. All data and materials in the grant application should appear in the data management plan. It really shows that you've thought through how your research is going to happen, and really is evidence of the feasibility of your project. And later on, decisions that you have to make about sharing and preservation hinge on the types of data that you collect. What is considered data? Types of data and files really is any materials that you are collecting throughout your research process. So this can be physical collections, this can be brain scan images, spreadsheets and statistical files, interviews and focus groups, field notes, audio, video, and statistical code. You don't have to share everything. So some of your almost notes to yourself, your preliminary drafts, personal notebooks, proprietary information does not have to be shared. So when we talk about protecting data and storing data securely, there are some acceptable forms of storage and some not acceptable forms of storage. When it comes to protected health information and sensitive data, the managed servers at the academic health center are protected. Encrypted drives or containers, and also box storage, which is a new option at the university this year. Steve, would you like to come up and talk a little bit about that right now? This is the perfect time.
Box is a really important new resource that's available at the university. What's the name of the group? HIPAA the
Center for Excellence.
HIPAA Center for Excellence, which is AHC and OIT and others, have made this available for you to store private data. It's really designed for HIPAA data, and there's really the place at the university to keep HIPAA data. But it also applies to any other private data. It's a good resource to keep any private data stored safely. And
It's not, this is not specific to AHC.
no,
No.
it's not.
We got access.
It is
Right.
university-wide research that's available to anybody at the university, students, faculty, staff. to
Is
store
there
private data.
unlimited in the storage capacity?
Pardon?
Are there capacity limits?
There are no total capacity limits, unlimited storage. In reality, that may not be totally true, I've found in the past, but just technically speaking, that's the kind. There's a 15 gigabit limit on any single file that can be stored there. And it's available now. It was made available only recently. We are trying to push people in the college to be aware of it, know it's there, know how to use it, and use it when appropriate. And our technical coordinator in the building is prepared to help you one-on-one, set it up, and start using it. You need to have Duo set up. If you don't already have Duo set up, you need to do that first, and the technical coordinator can help you with that. And then can help you get started with Box. And, they're not really able to give you a lot of advice, administrative advice on that, but they can provide you technically getting it set up and help you use it.
So Duo is more easily accessible to the common person now at the university? Because for a while you needed like basically ironclad, like 4 type pages of, signatures to get that.
No, it's readily available to
Okay.
anybody. And the technical
Okay.
coordinator can help you set that up.
Okay, I've already got it.
Okay.
That's not fun.
No, I do think they did make changes, because I think Gene put out in the Burton brief, it was a challenge of, if I can do it, the rest of you can do it. So I think they made it streamlined, because you're right, it was tricky.
We sent an email to Gene in one evening at the end of the day and said, we want you to help promote Duo. And an hour later, when we said, well, we will help you set it up, we'll get somebody to walk you through it and everything else. And an hour later, she said, well, I set it up for myself, I'm all done. So it really is not hard to set up. And again, it is available to everybody, students, staff, faculty.
But that's not up here, is it?
Duo is an authentication.
Oh, it's not that, okay.
To help you protect, really it gives you two-factor authentication, which is important for private data.
Yeah.
Because you don't want somebody to just get your password and know they have full access. This will help prevent that from happening. Yeah. Okay, talk to your tech coordinator, get it set up.
When we're talking about, thank you, de-identified data, in addition to free storage is Google Drive. So it is appropriate to use that when the data identifiers have been removed, personal identifiers have been removed. As far as the other options that some people try to use sometimes, like sharing information over email or using Dropbox, these are not university owned or sanctioned. We don't have contracts with them. So really they have no accountability without a university contract. And you definitely don't want to share anything over those venues that you wouldn't want to accidentally become public.
Can you say a little bit more about that? Because like we use Gmail, right, which is Google, and how is that different from Drive?
Well, you are not supposed to share any protected information over email.
Yes.
So email, the main thing with email is that if you upload an attachment, anyone who intercepts your email that's traveling to those different servers can get that attachment. A better option if you wanted to communicate via email is to send a protected link. And depending on the sensitivity of your data, you could do that in Google Drive with restricted permissions or in Box. They have link options. And that way, even if someone were to intercept your email, which is pretty easy and why we know, then they can't get access. Does that make sense?
Yeah, yeah.
So in order to protect your data, we recommend using the 3-2-1 rule. Having 3 copies of your work, 1 working copy, and 2 backups on 2 different types of storage, and that can be a server and a cloud storage, and at least 1 copy off-site. One of the reasons that this would be so important, this is a true story from Alicia's former life. At the University of Michigan, the North Quad flooded 4 times in 5 years.
So that flooded once. I was in psychology, and our psychology building flooded 4 times, and our labs were drenched, and it was a disaster.
And these are actual pictures from,
North Quad, yeah, another building.
yeah. So natural disasters happen, and plumbing happens, and things get lost and destroyed. So how will you document your data? Alicia's going to take over for a little bit here.
So yeah, in addition to thinking about the individual files you have and how you might be storing them securely, the next thing a data management plan would want you to describe is how you're going to collect the documentation and how you're going to document what you have. And there's a lot of good reasons for why they're asking this. This is probably one of the most important steps to be thinking about in your research workflow, is how you're going to keep track of all those files. And this promotes reproducibility, which is a huge thing now and important in many of the social sciences, transparency, and makes you more efficient if you don't have to reinvent what you've done later. Often documentation are love letters to yourself 6 months from now when you have no idea what it was you were doing on a specific research project. So it ensures it can be understood later, whether that's by another person or by you, who often feels like another person when you come back to an old project. And there's a lot of things that you should document. The short answer is you should really document everything. It's not always feasible. So some good ideas to think about are sources of data. So if you are collecting your own data, capturing those experimental protocols or other kinds of protocols or surveys, where you collected it, information about the dates and locations, and how they were collected. If you are collecting data from the web or from another database, having that source information, whether it's another researcher and you have a data use agreement, having that source and when that use agreement came about so you know when to delete it. It's also good to keep in mind. Study decisions are really important to write down. So things like, why did I run this condition and not that condition? Or why do I apply this code to this section and not this code to this section? These are things that are easily decided in the spur of the moment in a meeting, and then you go back a few weeks later and don't remember why those things were. So making a plan on how to write those things down and capture them is good. Statistical analyses. With a growing trend towards tools like R, which I think is pretty popular in this college. Is that true? Do most people use R for statistical analysis? So making sure you have syntax that underlies your analysis and that it's well documented, what you're doing, not just in the model testing, but in all that pre-processing, merging, wrangling of your files you do beforehand are documented. The software and instruments you use, this is especially important, as Shanda mentioned, because sometimes softwares become obsolete. If you use R, like I do, packages change over time. Sometimes what you've done in one statistical package, you can no longer do in the updated version, or it's a slightly different syntax. If you're using any odd instruments or proprietary software to collect, for example, I did psychophysiology recordings in my graduate work, and so that data I can no longer get at because I don't have that software anymore. And also where data and documentation are stored. This seems pretty meta, but can be really helpful, especially if you have a lot of bits involved in your workflow, and maybe you have some information you have on Box, maybe your participant list or your identifiers or raw data. And then you have other things you've shared with collaborators in other places. It's important to know where all those pieces are when you come back. Future research ideas and plans. This is also another one to keep a running text file going. Jot those things down to flip away. How should you document it? Well, there's a bunch of different flavors of how to document it, and I would encourage you to think about your own workflow and where in the process and what tools you're using can best capture this information. Some options that are popular include research logs. This can be like a lab notebook or something less formal. In the statistical syntax, data set metadata, and code books. And there's no one catch-all perfect workflow or perfect way to document things. The most perfect workflow that works for me may not work for someone else. So it's about figuring out what you can do within your own workflow to capture this information. And I'm just going to go through some examples of each of these. So a research log, sometimes this is a README file. So this is a nice centralized location where you can keep a running log, whether it's something really detailed, where each time you sit down with the data set, you're typing through your thoughts, you're writing up what you're doing, why you're doing it, what you found. Or it can be something more general that you might share with the data set at the end that describes what you did, who contributed, why the data was collected, and all this metadata about your data set and project that other people will want to know and you'll want to remember later on. The libraries have a really nice README file that we encourage people to use who deposit public data into our data repository, which Shannon will talk about. So if you'd like to take a look at that and use it for your own purposes, it is available. Statistical syntax, this is a nice way to capture documentation in an automated way. So there's a lot of different ways to record your analyses. If you're an SPSS user, breaking away from the point-click drool and hitting paste instead of OK, so you keep a copy of your syntax in a syntax file. In R, obviously, you would want to work with written scripts, but there are a lot of functionalities with RStudio to tie together your analysis and interpretation using things like R Markdown or knitr and Swede that keeps output and scripts together. So those are really nice options for documenting your work. Make comments liberally in your statistical syntax. I sometimes write a lot in my syntax, but it helps later when I come back and I remember where I left off. This is really helpful if you are working in spurts and you come back to it. I find one nice thing I've been doing to myself lately is I write a start here, this is what I'm thinking of doing, and this code isn't working, figure out why. And so then when I come back, it's easy to jump back in. So that's another way documentation can actually help you be more efficient in your own work. I also create a lot of white space in your syntax files, so it's easier to read. I included a link down here. Mantra, which is based out of the UK, I believe, has a lot of nice data handling tutorials for different statistical packages you may be using. I just want to show you a couple examples of syntax. So this is actually an SPSS syntax that I and a colleague wrote when we were curating a data set and adding some metadata. And you can see I used the comment codes as kind of headings, a lot of white space, a lot of written out long form comments to help me keep everything together. I do the same thing in R. I sometimes make big top headings with all my metadata about what the heck this script does and what it takes in and where it's supposed to live and when I modified it. And then setting apart each chunk. Especially useful if you process things and then you analyze things and you visualize to have those set off. So it's easy to find in your script. And I have this template too. I'll link to it online if you like how that looks. Data set metadata. So there are also ways to tie in some of this documentation within your actual data file. If you're using SPSS or used to using SPSS data or SAS, those things are really nicely bundled together, your value labels and variable labels. R has attributes that you can use in the same way. If you've ever read an SPSS file into R using foreign, you can run the attributes command and see how that metadata is stored in R. So you want to do variable names, what they are, make sure they're descriptive and not just V1. Variable labels, so those can be the question text, and variable values, so what does a 1, 2, 3 actually mean in your data set. And there's some good best practices for using Excel too, so those of us who are using Excel, make sure you have descriptive headings, just like you would in a statistical package. If you use abbreviations, maybe you want another workbook page where you have the list of abbreviations defined, or have your variable names or labels there. Formulas, if you're using formulas in Excel, it's a good idea to have another page where those formulas are typed out as text instead of embedded in case the link breaks or anything goes wrong. And noting any modifications. So if you had to copy and paste or input a lot of data, note that somewhere in case there's something that went wrong. And also what any other things that are in it. I like using color if I'm using Excel, and it's easy to go back and be like, what does that yellow mean again? And so making sure to note those things as you're working. And so as part of our curation process in Drum that Shanda will talk about in a little bit, we have some tools to help you extract this kind of information from an Excel file, so we can help you out with that. Code books are another way. Any of you who are using data from other people, from popular repositories like ICPSR, they often have really great quantitative code books with their data. So things like variable names, variable values and labels, the survey questions, codes for missing data, descriptive statistics of what's in the data. But there's also qualitative code books, so if any of you are doing interview data or any kind of textual analysis, it's good to have a code book of the codes you're using to describe that. So the description of the code, what would be included in that description and what would be excluded. Sometimes it's really easy to make decisions about what's in and out and then forget those decisions down the line. So it's a really great idea to have those guidelines in a code book in your documentation. The other trouble with staying organized is sometimes your inbox or your documents folder can look like this. Hopefully not this bad, but we've all been there. The embarrassment of someone looking over our shoulder and looking into our project file and seeing horrifying things. So making plans to organize your files is a huge part of data management, so you don't end up like this poor person. And there's a lot of different ways you can organize your folders. One tip that I've read, Scott Long, who is at the University of Indiana, at Indiana University, I believe, has a lot of great advice on how to structure your workflow for analysis. And one thing he said that really resonates with me is that once you come up with a folder structure, try to use it for all your different projects. And that will help you remember where things are, and as you go back, you'll know kind of where the same things, where to look for the same things if you're using a consistent structure. And there's a lot of different ways to organize folder structures depending on how you work and what works best for you. By data type, maybe you have a lot of different data types that you're analyzing, so it makes sense to organize your folders by type, databases, text, images. Maybe it makes sense to organize by research activities, so maybe you have two arms of the study, one's more survey-based, one's more interview-based, does it make sense to organize like that? Or by materials. So I personally tend towards this last folder where I have a data folder, I have a documents folder, and then within one I have a raw data, scripts, and a process data folder, and so on and so forth. But choosing one that works for you and sticking with it. There's also some tips for file naming, and having a plan of how you want to name files is helpful ahead of time, because then you'll limit the number of files, for example, in your literature folder that are just named with the same gobbledygook that it downloads. If you ever downloaded articles, they're not very clear. So be descriptive in your file name, and you actually have up to 255 characters for the whole file path. So that leaves you quite a bit of wiggle room for file naming. So instead of naming something like interview.txt, put the date, put the site, put some sort of context in there, so when you see that file, you'll know what it is without having to open up and take a look inside. And make sure this is in the file name and not just in the folder structures, although it is great to have folder structures that are descriptive. Don't let that be the only place that information lives. Because if you're sharing a file with a collaborator, or if you accidentally save that file somewhere else, all that's gone if it's just in your folder structure. So it's important to do it both in your name as well as in any folder structure you have. Again, use consistent structure. It'll help yourself, it'll help in a collaboration, so everyone's on the same page of where to store things. And it's also important to use numerical dates, so if you're going to be dating things, especially if you're going to have them at the beginning, or if you have a lot of files that are named the same and you have a date to distinguish them, naming it year first, then month and date, rather than some other combination or using the alphanumeric date will save you a lot of heartache, and I'll show you why on this slide. This mainly comes from sorting. Inevitably, the date timestamp or the date last modified by on your computer will fail you. So it's not a good idea to rely on that for sorting. So if you have dates, use the smart naming scheme to help you help yourself. So here I have it listed by the typical month, year, date. You can see once I sort it, it doesn't know that 12 should come after 8 because it sees it as 1, 2. And then if I start collecting other years, I'm going to have all my Februaries together. So February 2016 is going to be there too, and that's just a mess. So a better way is to start year, the month with a leading 0, and then the date. And so then when you sort it, it will sort nicely for you. The leading 0 is also really important if you're thinking about versioning. So if you have files from different days, maybe you have different runs or different tests, experiments, you'll want to use a leading 0 to solve the same sort problem where it thinks 1 and 10 should come right after each other instead of 10 following 9. But if you say 0, 1, 0, 2 through 10, then it will sort in the correct order. Yeah.
Can you go back to your file name?
Yeah.
And can you say something, so like using the underscore was a little bit of a throwback to like the Unix days and
Yeah.
things like that. Is there any reason to use underscore rather than hyphen, or some, God forbid, some people use dots?
Yeah, don't use spaces.
Yeah, obviously.
I think I tend to use underscores for readability. I haven't run into an issue for file names for me where underscore versus dot matter. I tend to use them just for readability.
So it used to be a big deal because
Yeah.
that would be the file extension. So,
Right, right.
you know, and space now is irrelevant actually with most common newer computers. So.
Mhm. Yeah, I only run into trouble when I'm reading in scripts into R or doing any kind of bash.
Sure, you can
stuff.
code it, right?
Yeah, yeah. So I would suggest stay away from spaces, although you probably won't run into issues. And then I just do it to read. Great question.
So I've been here long enough that my file structure goes many, many levels deep. So I have some restrictions on how long my file names could be because files that I lose when I transfer, they're too long. The string is too long. Any suggestions about that?
Yeah, a nice way to do it too is to make sure your folders aren't named too long. So a nice thing I've said is, or I've read, is to use some sort of acronym for each product or project instead of writing out the whole thing. So the more you can shorten up at your levels, the more you can maybe flatten the hierarchy. And I'm a long hierarchy person too, so it's hard. But the more you can trim in spots where the description isn't as important and leave it for the file name, that would be my advice. But I have actually run into the same thing where I've been over my 255 characters. Version control, this usually leads to us having a lot of different file and dates. So if you know you're going to have a lot of versions, you want to list version numbers with those leading 0s, thinking about how many versions you anticipate having. And you also want to think about, especially if you're working collaboratively, how many versions you want to keep and who's in charge of deleting them. If it is something where you're making a lot of different versions, where maybe you're having some folder clutter and they're not important to keep older versions, so who's going to delete them? At which stage are you going to keep a version? Often it's good to have some milestone versions, so if you start going off in another direction entirely, maybe keep that one. If you submitted a publication, having a version of the data associated with that submission, associated with the resubmission, are all good ideas. And if you can, assign responsibility of these master files to one team member, so you don't get people overwriting and deleting things that shouldn't be deleted. Another good, yeah,
I was just gonna ask about versioning, because that's, to me, one of the most attractive things about Box,
yes.
is the versioning capabilities.
Yes.
And would you make those same recommendations with the, considering that bugging is kind of built in?
Yes, and that's exactly my next slide. So Box is, thank you. I should plant you in all my Box, this would be great. Tools that have built-in versioning, I think, are the best. So the more that it works in your workflow to use built-in versioning, things like Box and Google Drive both have this built-in revision history. There are also tools like Git and GitHub if you're using code or statistical syntax. It's pretty useful. So this can save you that file clutter because they basically do the versions for you, and then you can see back in time the revision history and see what the changes are. If you use Git, there's options to leave yourself little love notes, little messages on what you did in that version, what's different. In Google and in Box, you can peruse through the different versions of them. If you're unfamiliar, in Google Docs, it's under Files, See Revision History. In Box, I think it's the 3 little dots next to a file. You can click on it, and there's some sort of version. I forget what it's called exactly, but it looks very similar to Google version history. And you can restore different versions. So if you decide to revert back to something else, you can store it. I recently found that when you revert, it actually puts your reversion as the new version, so you can still undo, which is nice. So if you decide you want to undo your reversion, you can go back to where you were without a problem.
And at some point you change the name of the file.
Yeah. Once you make a copy or change the name, I think in Google you can still change the name and it won't upset the file, but obviously in other programs it would. You can also do it in MS Word. There's some capacity for this, especially comparing versions. So if you have a V2 and a V5 and you're not quite sure how they differ, in Microsoft Word you can use the compare versions function. It will show you the differences between those two files. So there's some capacity for this in other programs as well.
You have to remember to turn that on, and if you turn it off, if you clean for sending it out, those things go away for you.
Right, the track changes. Yeah, so the track changes are one way you can do the revision history, but if you have 2 different files, this is one way you can compare those two. Yeah. In Google Drive, one thing that has always bothered me is that the search function is really bad, and I tend to name things that are very similar. You would be maybe not surprised how many things are named data management in my Google Drive. So it can be hard to find things. One tip I learned from Amy Riegelman, who's actually the EdSite liaison, is that you can add some tags or metadata to help you help yourself find things in Google. So she had an example with, she has a project called Money Smart Week. It turns out if you click on the information, there's this little description box underneath, and I'm sorry if you can't see, it's cut off a little bit, and you can add tags. And so those tags will be hit when you go to search for anything. So if she forgot that it was Money Smart Week, but remembered financial literacy, this would still show up.
Is that available in the Microsoft suite?
I'm not sure. It's available on Google Docs. There are tags in Box that can do the same kind of thing, but in the 365, I'm not sure. Yeah.
Do you recommend tagging and folder structure, or one versus the other? I mean, I prefer tagging
Yeah.
usually, but...
It depends on how you work.
Okay.
For me, I was really excited about tags for about 2 weeks, and I tagged about 30% of my files, and I never did. I never searched from that way. I'm a folder-based person.
Sure.
So it didn't work out for me. I know a lot of people who are more of a search person, and tags work really well for them. And there's some, semantic kind of programs that can help you do better with tags. So it really, I would say whatever works. If you're the searching kind of person, tags are great.
Right.
If you're the file structure person, tags might not be useful. Other questions? All right, So I'm going to turn it back over to Shannon, who's going to talk a little bit about data sharing and privacy, so kind of talking more along the lines of what Tom had talked about before.
Thinking about how you're going to share in data and handle privacy. The why, it really depends. There's the possibility of grant expectations. There's possibly a publisher requirement. You want to market yourself and increase your citations, or maybe you just have a burning desire to get as much data out into the world for transparency as you can. But for whatever the reason, even when you're working with sensitive data, it's not all or nothing. There's also always a gray middle. And especially when it comes to grant requirements, saying that you work with sensitive or private data is not an acceptable excuse for not sharing it into the required repository. So a couple things to think about right from the get-go. What are the IRB considerations? What did you write into your IRB application? What did you write into the consent form that you had your human subject sign? What are the copyright and intellectual property considerations? Of course, data privacy issues, identifiers direct and indirect, and where and how to share your data. There are circumstances where the funder requires that you share it, but they don't specify where. So in considering the IRB, there's some really common language that's used by researchers that's maybe not the best language to use when you are planning to share your data or required to share your data in the end. There is often a promise made to eventually destroy all data, and that's maybe not the best option or idea right from the beginning. Instead, you can promise to destroy things like the direct identifiers, the linking information. Audio files usually have to be your IRB wants those destroyed because voices can be detected. Instead, you can put that you will retain and preserve the de-identified materials or data that you're collecting. Another common language used is responses will only be seen by the research team or by bona fide researchers. In lieu of that, you can say that identifying data will be kept confidential and only de-identified data will be shared publicly. And third, another comment is that data will only be shared in aggregate form. And when you are sharing data sets, it's pretty difficult to get in your entire data set, which may have thousands of lines, into aggregate form. You kind of shot yourself in the foot if you wrote it that way. So individual responses will only be shared in ways that will not identify the participant is a good alternative for that. So, these are things that need to be thought about right from the very beginning. Trying to avoid restrictive language in general is the best option, I think. I think the reason a lot of people put such restrictive language into their applications is because they think that that's what the IRB wants them to put into it, and that's not necessarily the case. The IRB is there to protect participants, but also ensure integrity in research, and they understand that there are sharing requirements now. They want to just see that you have a plan for how to handle that responsibility. So this is our one slide on copyright and intellectual property. It is unbelievably complicated. There are university policies, there are funder policies, there are publisher policies. So we have links here for you guys to all the U of M policies on intellectual property, copyright, and the data management policy. This is the lovely Nancy Sims. She is a lawyer and a librarian, and she handles all copyright questions for the University of Minnesota. So if you have any questions about your data and sharing, I suggest you contact Nancy and have a consultation with her. So when it comes to sharing human subjects data, it's really important, of course, as Tom talked about, to de-identify data for broader use. You have to, first of all, evaluate direct and indirect identifiers. He was absolutely correct. When it comes to HIPAA data, there is an entire list, not exclusively, but some of them are name, of course, geographic subdivisions smaller than a state, reporting individual ages over the age of 89 is one of their categories. Fax numbers, of course, social security numbers, license plates, things like that are all listed in there. But you also have to evaluate what's left in your data set when you take that out. Are there still categories and variables in there that when you combine them with each other or with other public data sets, individuals could be identified? And that has been the case in a couple of famous circumstances. Well, there was a study done with Netflix alone, and I think based on 6 movie choices that you made, they have an algorithm, somebody made up an algorithm that could identify who you were. The U.S. Census Bureau determined that 87% of the population can be discoverable based on your zip code, your sex, and your date of birth. That's all they need. There's actually a website that you can test it out for yourself. It's called aboutmyinfo.org. It's kind of fun.
You know everybody knows to type that in right now.
Yeah, yes, if you want to, absolutely. So I just retested myself this morning, and based on my zip code and my sex and my date of birth, it was one of me. And so if that type of information was released to the public, and it was sensitive information, I could easily be identified. But when they collapsed the age category, within a 5-year span, I was one of 1,500 people.
So is it date of birth or age?
It's date of birth.
Okay, so
But of
if
course,
they
it's
convert
when
data,
they
if they convert it to ages before we de-identify, or as part of the de-identification, that was sufficient.
well, but then you want to make sure the date when they took the survey and they were that age, that only gets a year, yeah.
Yeah, right. Some solutions are recoding variables, collapsing categories that have small frequencies. These are some of the ways that you can start protecting, further protecting participants when you are still trying to keep some of that indirect information into your data set. There are more complicated methods, and if anybody has any questions about that, you can talk to Alicia. So you want to make sure you're choosing appropriate access methods when you are planning on sharing. Not all data should be shared publicly, and there are methods to share data without putting it in a completely public repository. You can share through restricted access, so place an embargo on your data so that it's housed in a repository, but someone who wants to see it has to contact you and request that. So it's still being maintained and protected for you by the repository, but it's not immediately accessible to the public. And you can use repositories with data use agreements. So our data repository, like I said, is called DRUM, Data Repository for the University of Minnesota. We have a data use agreement that we require our submitters to use. And do you want to talk a little bit more about that and the legality of it, Alicia?
Yeah, well, and it's, so the data use is for people who submit data. It's a public repository, so we don't want any identifiers. We look to see if you have identifiers. We ask for your IRB to make sure that you aren't promising to keep people's data not shared or restricted to the researcher. There's not a specific data use agreement per se. There's a terms of use for the library. So anyone who downloads public data are agreeing to the terms of use. And I know the libraries went through, I think, OGC or something when they put that together. It is public data, so there isn't any contract like you would have with a data use agreement when you're using it. And so for that reason, it needs to be scrubbed more aggressively in terms of what you can have in there. than things that you would have, the agree not to identify, or agree not to bind with anything, or agree not to share further in a data use agreement. So a lot of repositories, I think you have a slide on ICPSR, have data use agreements in place, or have established ways of sharing where people have to jump through more hoops and have more legal restrictions in order to use your data. That helps.
You can also apply a Creative Commons license to the data that is submitted to the repository. For example, a CC0 would be no restrictions. A CC BY would require that the user of your data set give you credit for the data.
That's kind of like a patent or a copyright.
It's a license for the use of the copyright, yeah.
So to kind of summarize, considerations would be looking at the sensitivity of the data that you're using. I have a good example from my past life. I used to be a research coordinator in the School of Public Health. I got my MPH versus my library degree, actually. And we did interviews with the local Somali community on sexual health. And so when we had to clean the data set, we had to be really careful about releasing age in combination with education level. And we had to put in aggregate form a lot of our demographics because of the extremely sensitive nature of sharing sexual health information within the Somali community. So consider promises made to research participants. Look very closely at what your consent form said and what your participants expect you, how they expect you to use that data that they provided for you. And consideration would be with whom and how the data are shared. So like I was talking about earlier, we do have a repository at the U of M here. It's free for all U of M affiliates. We take all data types and topics. If it's new to us, that's not a problem. There is a team of about 5 of us who work together to come up with solutions, and we can pull in other experts in the university if necessary, but like our GIS specialist, if we get a geospatial data set. But yeah, we accept a wide range, including qualitative data sets, if that's something that you think would be possible or desirable to you. And it is public data sharing, like Alicia was talking about. There is also, yeah, did you have a question?
You go ahead and finish the moment.
A typical, common, popular, I guess, social science data repository is the ICPSR, and that is from the University of Michigan. Or is it Michigan State?
Michigan.
Thanks. So you guys are familiar with it, some of you. So if you're not sure where to submit your data set, we are happy to meet with you in consultation and help you find where people who would discover your data set usually go to find them, or where do other researchers in your discipline submit their data. Drum is a good opportunity if there is no other place, but you know, that's not always the ideal option. There may be something like the social science database of ICPSR, which would make your data more discoverable. Do you want to say anything more about ICPSR?
So this is like the other side of academia, or where you're sharing the data in a offshore, in some cases, vendor who's using it to market their software. So you can share data through those vendors as well, but probably not the best strategy, right?
Well, these, I guess, in terms of vendors, these are archives, so they're really, there are others out there, maybe other repositories out there that are different, but in the case of Drum or ICPSR, their goal is to really archive, preserve, and share the data. Yeah.
Other questions? Yeah.
This is a little bit of a one-off, and if you can't answer here, this is okay. But one thing that came up for us yesterday was talking about our technology staff in IRB. as, in terms, and all of it, it also came up in terms of if we're considering, do we need somebody in the role of a data manager? And what the typical practices in IRB will list those people as people that have access to data. And what is like, you know, what's the typical protocol for that? Do you include them, do you not include them, are we being too granular? If anybody can answer that.
I'll let you.
So we've struggled with that. So I work in a research team in CLA where we often have access to people's data. And you think about the database administrators or your IT professionals, they also have access to your data in certain ways. And we've gone back and forth on it. I think if it's a staff that may be accessing it or using it, like a data manager, we would say at least that office would have access to it. I've seen that less commonly, they point out all the IT people that could possibly have access to it, so.
That was the question, is how, so we could use somebody that's in the role of data manager as appointee for.
Right. That's what we've done in the past.
Okay, great.
The other side of that is, what are the obligations for training for anybody who's in that bucket? Right?
For the
tech people who have access to data because of their tech person.
Yeah. We make all of our students in our office do HIPAA training and city training and all that.
Cities required.
Yeah.
Any other questions on that? Okay, so we're finishing up with preserving your data. Considerations would be how long. Forever is not always a realistic plan. So at what point do you kind of let go? And how will you do it? Common terminology, again, used on IRB applications is it'll be kept indefinitely on the hard drive or server, and which is not very detailed or well thought out plan. So storage versus archiving, I think, is a common misunderstanding. I think people get tripped up in the archiving part and think that there's some mysterious thing that you have to do at the end of your research project to archive it. But really, storage is how you are managing and storing your data during the active part of your research, including your backups. And archiving is really what happens to your data after your research project is over. So sometimes moving between working and long-term storage can be obvious, such as submitting it to a repository. And sometimes it requires an intentional action of copying the final files into a new directory or backup location, or going through the working storage location and cleaning out drafts and old working files. A huge consideration for archiving your data is your file formats. Like we've been talking throughout our afternoon here, software can be proprietary, file formats can go away, and for long-term viability of your data, it really needs to be in a proprietary format. So there are some options here for textual data. RTS and TXTs are the best options there. For tabular data, tab and CSV. Images, TIFFs, audios, waves, video, MP4. I think we're all familiar with these. Documentation and PDFs are super common. These are the ideal formats in which to store your data for long-term preservation. And when submitted to a repository, if you haven't already transferred them into these formats, that is something that is done by the archiving team. And that is maintained over time by the archiving team as well.
On that point, is there an easy way to rename? Do you have to convert the file in order for this to work, or can you change the name of the file?
It depends. We do have software that will take care of the tabular data. I think Word to TXT is pretty easy. But I'm unfamiliar with the other ones, the waves.
Yeah, typically you need to do it through a conversion, not just rename the extension, that will break it. Bad things will happen.
So again, I just want to plug for the drone consultation team. If you have questions about doing that yourself, or if we can do that for you, please just call us and set up a consult. We'll be happy to sit down with you and talk about long-term preservation file formats.
Do you suggest like OCRing the PDFs at all, or not?
Yeah, it's typically good for usability. I think there's a special PDF A for archival storage, but I'm not an archivist, so I don't know how that works. Do you know the PDF
I
A
don't.
versus?
Our archivist made these slides. So next steps, who can help you? Do you want, okay. We have several resources on campus. Alicia and I are part of Research Data Services. We do presentations, we do tailored workshops. We're really kind of defining ourselves right now. So if you have a question about what we can do for you, please ask us. We're open to hearing those things. One thing that we strongly encourage people to use us for is data management plans for your grants. Those do come across our desk, and they can be faulty, and we can really help you think through the specifics and the details that would be needed in a really quality data management plan. Your library liaisons are Kim Clark and Amy Riggleman. I think Amy is the education site liaison, but Kim Clark is your library liaison. And Scott Marsalis is the kinesiology and social work liaison as well. So you can always contact them. We do online workshops, like I said, data management camps for graduate students. We have one coming up in January. So if you'd like to let any students know that we will be holding this workshop, the announcement will be going out very soon, I think in the next week or two. And then campus resource links. Some of our policies, our storage policies, the box self-help guide is really useful if you are going to be using that. Training for researchers and students at the libraries, and different list of management tools from the libraries. Further, this is resources outside of our institution, but are also really useful, including data management templates and different data management tools that we recommend to folks when they come to us. Our contact information, if you have any questions in the future. And that's it. Thanks so much, everyone.
Wow, that was very comprehensive.
Yeah,
Thank you.
you're welcome.
But two quick
Thank
hands.
you.